right, so in yesterday's lesson, we learned polynomial long division as well as synthetic division, and I'm sure most of you preferred synthetic division to the polynomial long division, which hopefully you do because we are going to be using synthetic division very frequently throughout this unit and later on in later units and later math courses. So both of our goals involve synthetic division. We need to be able to use synthetic division and a given zero to write a polynomial in factored form, so get it completely factored. And we also need to be able to use synthetic division and a given zero to find all the zeros. So if you're given one of them, we need to be able to find all of them. The factor theorem is what we're focusing on today, and it says that any polynomial, so f of x, has a factor x minus k if and only if f of k equals 0. So what that is saying is it's only a factor if when you plug that in, you get 0, which makes sense because a factor means it divides it evenly. So if you got a remainder, then it wouldn't be a factor. So this f of k equals 0 means that there is no remainder. So if we divide it and have no remainder, that means we're going to be able to use the answer row from our synthetic division to help us write the polynomial in factored form. That is like a step along the way to being able to meet the second goal, the find all zeros, because once it's in factored form, we can solve to find the other zeros. All right, so example 1, factor the polynomial given that f of k equals 0. So it's saying f of 10 equals 0, meaning that x minus 10 has to be a factor. So all we do is we set up our little synthetic division box just like we did in the last lesson. We put the 10 inside here. We put the coefficients of the polynomial in the top row again. So 1, negative 12, positive 12, 80. We draw our line and our dashed vertical line. Bring down the first term. And now we start our multiplying and adding. So multiply box times bottom, 10 times 1 is 10. Then add the column, that gives you negative 2. Then box times bottom again, gives me negative 20. Add the column, gives me negative 8. Then multiply box times bottom, negative 80. Add straight down, and I get 0. So if you don't get 0, you did something wrong, and redo it because it tells you in the problem that f of k should equal 0. Now, what this means, because it's important that we understand what we're doing, what this means is that I just divided this polynomial right here by x minus 10. And what I got was, remember what these stand for, that stands for x squared minus 2x minus 8. So what that means is that if I want to factor this, I've already got the x minus 10 because showing that this divided evenly means x minus 10 was a factor. So if I want to write it in factored form, I've got one factor. I just need to factor this one further. So I look at that. I know that it doesn't have a GCF. It's not a special product because 8 doesn't have a perfect square root, so that means it's factors that add. So I'm looking for what multiplies to negative 8 and adds to negative 2. So hopefully you know that pretty quickly. That's negative 4, positive 2. And again, think about what type of factoring you're doing. This is factors that add, so that means these answers go straight into the parentheses. So since this was an x squared, these are both x's, and I plug in my minus 4 and my plus 2. And so that is how we write it in factored form using synthetic division. So that's like our first learning goal there. So on this next one, I would like for you to try the exact same thing. So set up your synthetic division and try to write it in fully factored form. So pause it while you do that and then come back to check. So in our box, we set up the negative 6, then coefficients along the top row, so 3x cubed, 14x squared, negative 28x, and negative 24. So bring this down, dashed vertical line. So bring down my 3. Box times bottom gives me negative 18. Add the column gives me negative 4. Box times bottom again, that's positive 24. Add gives me negative 4. Box times bottom is positive 24 again. And I do indeed get 0. Again, if you don't get 0, you did something wrong. So what this means is that when I divided by x plus 6, because remember it's minus negatives become pluses, I get 3x squared. That's what this 3 means. This negative 4 means negative 4x, and this one means minus 4. So now I need to write that in fully factored form. This one is not a factors that add. I know it's not a special product. So this, because there's a number in front of the x squared, this is going to be a split the middle. So I'm looking for what multiplies to 3 times negative 4. So what multiplies to negative 12 and adds to negative 4. So that one's pretty easy too. Negative 6 positive 2 gives me my negative 4. But again, this is a split the middle. Think of what type of factoring you're doing. If I'm splitting the middle, that means I split this middle term here into these two. So negative 6x plus 2x minus 4. And now I factor by grouping. Some of you write parentheses around your groups. I really wouldn't do that because then you think that that's the factored answer. I just always do these little brackets at the bottom. So that first group has a GCF of 3x. When I factor that out, I've got x minus 2 remaining, which means that this parenthesis has to be x minus 2 also. So what do I multiply x by to get 2x? I multiply by positive 2. So now my final factored answer, here's the first parenthesis from my factoring by grouping, and here is the second one. So I bring down the x plus 6 that I've had since the beginning, and then my 3x plus 2, and then finally my x minus 2. And so there is our factored form. All right, so hopefully you feel comfortable with our first learning goal here. We can use synthetic division and the given 0 to write a polynomial in factored form. The big thing that people mess up here is when they go to write the factored form, they forget to change this sign. So if this is positive, it was a minus 10. If this is negative, this was a plus 6. So keep that in mind. Now let's look at our second learning goal. I can use synthetic division and a given 0 to find all zeros of a polynomial. And I wrote in big capital letters here, you have to find all the zeros, not just the real zeros, not just the ones that are factorable, all the zeros. If they're imaginary, if they're radicals, you have to find all of them. All right, so let's take a look at what that means here. So I'm going to start the exact same way. It's telling me that 3 is a 0 of this polynomial. So I'm going to start the exact same way with 3 in my box and lining up a synthetic division. So this one's 1, 1, negative 13, 3. So bring down my first term, box times bottom, add the column, box times bottom, and add the column, box times bottom, and add the column. So what that means is that this represents x squared plus 4x minus 1. Now, I'm not just factoring here, I am finding the zeros, which means I have to set this equal to 0. Now, some of these will factor, just like they did up here. This was factorable, this was factorable. This one is not. There's nothing that multiplies to negative 1 that adds to 4. That doesn't mean that you stop. That means that you have to solve it a different way. That's why we spent an entire unit on solving quadratics, because this is a quadratic and it's not factorable. We still have to be able to solve it. On this one, I think it's easiest to complete the square because there's no number in front here and the middle term is even, so you won't have any fractions or anything. So in order to complete the square, I need to move this over to the other side. So x squared plus 4x equals 1. And then add my blanks. So remember, I fill in the blank with b divided by 2 squared. So in this case, my b is 4, so 4 divided by 2 squared. 4 divided by 2 is 2, 2 squared is 4. To fill in the right side, remember I do the little swoopy thing, but this is just a 1, so 1 times 4 is 4. So on the left side now, factor that as a PST, that's x plus 2 squared. The right side, 1 plus 4 is 5. And so now I can take the square root on both sides. So x plus 2 equals plus or minus radical 5. Don't forget this plus or minus. And then subtract the 2. So x equals negative 2 plus or minus radical 5. And then it says find all the zeros. Don't forget to list the one that they gave to you. So this polynomial function has 3 zeros. You need to make sure you are listing all 3 of them. 2 of them are right here because the plus or minus is 2 separate answers, and then the other one is the one that they gave us, so x equals 3. All right, so I'd like for you to try the last one on your own here. Set up your synthetic division and solve what remains to find all of your zeros. So plug it, pause it, and then come back and see if you got it right. All right, so here my 2 goes in my box because that's what's over here. My coefficients, the x cubed coefficient is 1. The x squared coefficient is negative 6. The plain x is 21, and my constant is negative 26. So draw in my lines, bring down my first coefficient, and now start my synthetic division. So box times bottom is 2. Add the column gives me negative 4. Box times bottom again gives me negative 8. 21 plus negative 8 is 13 when I add the column. And then box times bottom again, positive 26, and then 0. Again, they're telling you this is a 0, so if you don't get remainder 0 in that first synthetic division, that means you've done something wrong. Okay, so now, because I started out with x cubed, that means this represents x squared, so it's 1x squared minus 4x plus 13 equals 0. So I already completed the square once. This one is not factorable either. There's nothing that multiplies to 13 and adds to negative 4. So on this one, perhaps another way of solving quadratics to review is the quadratic formula. So if I want to use the quadratic formula, remember that's opposite of b plus or minus square root b squared minus 4ac. The whole thing divided by 2a. Some of you have a habit of only putting the fraction under the square root. It's over the whole thing. So let's plug it in. Opposite of negative 4 is positive 4, plus or minus square root. B squared, negative 4 squared is 16, minus 4 times a, which is 1, times c, which is 13. And that whole thing is going to be divided by 2 times a, which is 1. So now I just need to use order of operations to simplify. So 4 plus or minus square root. When I multiply 4 times 1 times 13, I get 52. So that's 16 minus 52. The bottom, obviously, 2 times 1 is 2. Now when I actually do 16 minus 52, I get negative 36. So I've got square root of negative 36 and then 2 here. Now remember, when I square root a negative, that brings an I into my answer. So I know I'm going to have imaginary solutions. The square root of 36 is 6. So the 36 part gives me the 6, the negative part gives me the I, and then I've got over 2. Now, all three of these terms are divisible by 2, so I'm going to go ahead and reduce them. So that's going to give me 2 plus or minus 3i. So that is what 2 of my zeros are, because 2 plus 3i is one of them, 2 minus 3i is the other. Do not forget to list the original 0 that they gave you, which was x equals 2. So these are your zeros. Again, we didn't just find the real zeros. These ones were imaginary. You still have to solve for them. All right, so hopefully you are now a pro at synthetic division and you see a purpose for why we learned it in the last lesson. And that is it for today.